Good morning. Myself Dr. P.R. Krishnaveni, Associate Professor of Chemistry, Sasi Institute of Technology and Engineering, Tadapalligudam. Today I am going to discuss about the course objectives and outcomes of the course Engineering Chemistry. The course Engineering Chemistry is introduced to non-circuit branches. And this course consists of 5 units. First one is Polymer Technology. Second unit is Electrochemical Cells. And Corrosion. Third unit is Chemistry of Materials. Fourth one, Fuels. And the last unit, fifth unit is Water Technology. So coming to the course objectives of the first unit Polymer Technology is mainly introduced so that the engineering students will be able to understand the importance of the plastic materials or the rubbers which are used for household purposes. And not only that, the composite materials which are widely used in aerospace and automobile industries. And the objective of this electrochemical cells is to outline the basics of batteries and fuel cells. And the objective of corrosion is to explain how the mechanism of corrosion is being done and what are the methods are there to prevent the corrosion. And the third unit, Chemistry of Materials. The objective of this unit is to express the increasing need of the advanced materials which have wide engineering properties. And fourth unit, Fuels. The objective of fuels is to relate the fuels as an alternate energy source in many industries like textile industries, thermal power plants, automobile industries, etc. And coming to the fifth unit. The objective of fifth unit, Water Technology, is to explain how potable water is being supplied for drinking purposes and the drawbacks of the steam boilers. Water is the important material in many industries. So these are the objectives of this course, Engineering Chemistry. Now coming to the syllabus. So the Engineering Chemistry course is introduced for the non-circuit branches, as I said earlier. So these are the course objectives. So coming to the first unit, Polymer Technology. So polymer technology consists of mainly 4 parts: polymerization, so first part is polymerization, next one is plastics, third one is elastomers, and fourth one is composite materials. So coming to the polymerization, starting we have to discuss about the introduction. So in introduction we will be mainly discussing what is meant by a polymer and the process of polymerization, and here we will discuss about types of polymerization. So in types of polymerization we will be discussing about addition polymerization, condensation polymerization, and the next topic is methods of polymerization. In methods of polymerization, basically we will be discussing emulsion and suspension polymerization. Next topic is plastics. In plastics, we will be discussing about the compounding of plastics. Compounding of plastics means what the materials that are being used for the preparation of plastics. And next one is fabrication methods. Fabrication methods means nothing but the molding methods. So here we will be using 4 molding methods for the preparation of thermosetting and thermoplastics. So the 4 molding methods are compression molding, injection molding, blow film molding and extrusion molding. These 4 methods we will discuss here. Next we will discuss about the preparation, properties and applications of PVC, that means polyvinyl chloride, polycarbonates and bakelite. And next, in addition to that, we have to discuss about some of the examples of plastic materials which are used in electronic gadgets. And next, recycling of e-plastic waste. So next one, elastomers. Coming to the introduction of elastomers, here we will discuss about natural rubber and the basic unit in natural rubber. Next we will discuss about drawbacks of natural rubber. Next we will discuss about vulcanized rubber or vulcanization. And next we will discuss about the advantages of vulcanized rubber. So all these 4 we will discuss in introduction part. Next we will discuss about the synthetic rubbers. Synthetic rubbers means bunias, thiol and polyurethanes. These are called as synthetic rubbers. Here we will discuss about the preparation of synthetic rubbers, properties of these 3 synthetic rubbers and applications of these 3 synthetic rubbers. And the 4th part of this unit is composite materials. Here we will be discussing about the fiber reinforced plastics, conducting polymers. In conducting polymers, we will discuss about the mechanism of conduction in detail. And we will discuss biodegradable polymers, biopolymers, biomedical polymers. And coming to the outcome of this unit. The outcome of this unit is, at the end of this unit, the students will be able to analyze the different types of composite and plastic materials and they will interpret the mechanism of conduction in conducting polymers. Coming to the second unit. Second unit is electrochemical cells and corrosion. So in electrochemical cells, we will be discussing about single electrode potential. We will discuss about single electrode potential. So here first we will discuss what is meant by electrode potential. And we will discuss measurement of single electrode potential. Measurement of single electrode potential. Next we will discuss about electrochemical series. That means how this series is being constructed. That means here we will be constructing the series taking hydrogen electrode as the reference electrode. And next we will discuss about the uses of this series. Next topic is standard hydrogen electrode and calomel electrode. So the standard hydrogen electrode will come under primary standard electrode. And we will discuss about this calomel electrode, which is a secondary standard electrode. Next we will discuss about the construction of glass electrode. And next topic is batteries. So here battery means nothing but electrochemical cells which are stacked in series. So again coming to the batteries, we will discuss about primary batteries. And secondary batteries. And the examples of these primary and secondary batteries are dry cell, lithium ion battery and zinc air cells. And next one is fuel cells. Fuel cell means nothing but an electrochemical cell where the energy in the easily available fuel oxidant will be converted to electrical energy. So in fuel cells we will be discussing about hydrogen oxygen fuel cell, methyl alcohol oxygen fuel cell, phosphoric acid and molten carbonate fuel cell. So in these fuel cell we will be discussing in detail about the fuel, oxidant and the electrolyte that is being used. And after that we will discuss the advantages of all these fuel cells. And second part of this unit is corrosion. So in corrosion basically we will be discussing concentrating on the definition, and not only on the definition and the causes of corrosion. So corrosion means what? Nothing but the gradual decay of a metal. So coming to the cause of the corrosion, here we will be discussing which metals will undergo corrosion and which metals will not undergo corrosion, and the reason for the metals for not undergoing corrosion, all that we will discuss in detail here. And next one is theories of corrosion. In theories of corrosion we will discuss about chemical theory and electrochemical theory. That means here this dry chemical corrosion can also be called as dry corrosion, and this electrochemical corrosion can also be called as wet corrosion. After the theories of corrosion, we will be discussing about galvanic corrosion, differential aeration corrosion, stress corrosion. So these three will come under types of corrosion. So these three we will be learning under types of corrosion. After discussing about these types of corrosion, we will discuss the galvanic series. In electrochemical cells we will discuss the electrochemical series, and in corrosion we will discuss about the galvanic series. So this galvanic series has been developed basing on the rate of the corrosion. Next we will discuss about the factors that influence the rate of corrosion. After discussing all these, we have to discuss about the corrosion control methods. So in corrosion control methods, the first control method is proper designing. So here what we will discuss means how the material is to be designed so that the material can be protected from corrosion. That means if a material is undergoing corrosion, the design should be such that it should not lead to localized or intense corrosion. So how it should be designed? Designed in such a way that should not lead to localized or intense corrosion. So it should not lead to localized or intense corrosion. So in such a way we will be designing the material. Next one is cathodic protection. So in cathodic protection, what we will do means we will make the material to behave like a cathode. Why means corrosion takes place at anode. So now what we will do means we will make that particular material to behave like a cathode so that it can be protected from corrosion. Next control measure is by using protective coatings. So what are the methods we will be employing under protective coatings means surface preparation, cathodic coatings, anodic coatings, electroplating and electroless plating, taking nickel as the example. And the last topic of the second unit is paints. So in paints we will be basically discussing the constituents of paints, functions of paints and some special paints. So coming to the outcome of this unit. So at the end of the unit, the students will be able to utilize the theory of construction of electrodes, batteries and fuel cells in redesigning new engineering products. And they can also categorize the reasons for corrosion and study methods to control corrosion. Coming to the third unit, chemistry of materials. So coming to the part A of this unit, first one is nanomaterials. In nanomaterials, the first one is introduction. So in introduction, what we will do means we will discuss what is meant by a nanomaterial, and next we will discuss the preparation methods or the approaches for preparing nanomaterials. So here we will discuss about two approaches: top down approach and second one is bottom up approach. So the Soldier method of preparing nanomaterials will come under this bottom up approach. And next one is characterization of nanomaterials. So the characterization methods what we can use here are Bronner, Emmett, Teller, BET method, and SEM, that means scanning electron microscopy, and transmission electron microscopy TEM, taking the example titanium oxide. Next we will discuss the applications of graphene and fullerenes. And the next topic is carbon nanotubes. In carbon nanotubes, first one is types. So here we will be discussing about the single walled carbon nanotubes, double walled carbon nanotubes, and multi-walled carbon nanotubes. And next one is preparation methods. Coming to the preparation methods of carbon nanotubes, here we will be preparing the carbon nanotubes using three methods. First one is arc discharge method, second one laser ablation method, and third one chemical vapor deposition method. So we will be preparing the carbon nanotubes using these three methods. Next one is applications of carbon nanotubes. And the second topic here is thermal analysis techniques. So here we have to discuss about the instrumentation and applications of thermogravimetry analysis, differential thermal analysis, and differential scanning colorimetry. And coming to the part B. Part B of this unit. Part B consists of three topics: refractories, lubricants, and cement. Coming to the refractories, first we have to discuss about the definition. That means refractories are the materials which do not fuse easily, or these are the materials which do not melt easily. Why they don't melt easily means refractories will have high fusion temperature. That we will discuss in detail in the definition of refractories. And next one is classification of refractories. Here refractories will be classified basing on the fusion temperature, and we can discuss the classification basing on the chemical composition. And again, coming to the classification based on fusion temperature, they will be classified into three types as normal refractories, high refractories, and super refractories. And coming to the chemical composition, here the refractories will be classified as acidic refractories, basic refractories, and neutral refractories. So these three examples, that means normal refractories, high refractories, super refractories under according to fusion temperature, and classification based on chemical composition, acidic, basic and neutral refractories we will discuss in detail in the classification. Next, properties of refractories. So in properties of refractories we will discuss the refractoriness property, refractoriness under load property, porosity and thermal spalling. And next we will discuss about the failure of refractories. And second topic in part B is lubricants. So here we will be discussing about the definition. That means lubricants are the materials which reduce the friction when placed between two surfaces, and that phenomena is called as lubrication. And we will discuss about the mechanism of lubrication. And next we will discuss about the properties, definition of some properties and the importance of lubricants. And the third topic under part B is cement. Here we will discuss about the constituents of cement, manufacturing process of cement, and the parameters to characterize the clinker formation. So that parameters are lime saturation factor, silica ratio, alumina ratio, and next we will discuss about the chemistry of setting and hardening. And the next one is deterioration of cement. So coming to the course outcome, at the end of this unit, students will be able to synthesize the nanomaterials for modern advanced engineering technology, and they will be able to summarize the techniques that detect and measure the state of reaction, and they will illustrate the commonly used industrial materials. And coming to the fourth unit. Here in fourth unit, starting we will discuss about the introduction of fuels. That means here we will discuss about natural fuels, and artificial fuels. And next we will discuss about the calorific value. In calorific value only we will discuss about higher calorific value and lower calorific value, and we will practice some problems using Joule formula. So Joule formula is used to calculate the calorific value of a fuel. And next we will discuss about the proximate and ultimate analysis of coal sample. In proximate analysis of coal, so in proximate analysis we will be estimating the amount of moisture content. We will analyze the amount of moisture content in the given coal sample. We will estimate the amount of volatile matter, amount of ash content, and carbon content. That means fixed carbon. So using proximate analysis we are going to analyze the moisture content, volatile matter, ash content and the fixed carbon in the given coal sample. And next analysis of coal is ultimate analysis. Using ultimate analysis we will be analyzing the percentage of carbon and hydrogen, percentage of nitrogen, percentage of sulfur and percentage of oxygen. So these will be analyzed in ultimate analysis. And after that we have to discuss about the significance of proximate analysis and significance of ultimate analysis. So after discussing about the significance of the proximate analysis and ultimate analysis, we will discuss numerical problems on that. Next topic is petroleum. In petroleum, we will discuss about the refining of petroleum. So in refining of petroleum, that means in refining process, we have to discuss about the removal of solid impurities, removal of water, removal of sulfur, and the last important one is fractional distillation. So in fractional distillation, we will be separating the various components of petroleum like petrol, diesel, kerosene, all that we will be separating, we will be getting in fractional distillation. And next one is cracking. So in cracking, we have to discuss about the thermal cracking and catalytic cracking. After that, synthetic petrol. So this synthetic petrol will be synthesized using this Fischer-Tropsch synthesis. And the second method for synthesizing synthetic petrol is Burgess method. Next we have to discuss about petrol knocking and diesel knocking. And next, octane and cetane ratings and the anti-knocking agents which are used to reduce the petrol knocking and diesel knocking. Next we have to discuss about some alternate fuels. So the alternate fuels what we have to learn means biodiesel, ethanol, methanol, natural gas, LPG, liquefied petroleum gas, compressed natural gas. And the last topic of this unit is flue gas analysis. So this flue gas analysis will be carrying or will be analyzing using offset apparatus. And next we have to discuss about few rocket fuels. And the outcome of this unit is the student will be able to differentiate petroleum, petrol, synthetic petrol, and they will gain the knowledge how they will be produced. And they will study alternate fuels and analyze flue gases. And the last unit of this engineering chemistry course is water technology. In water technology, we have to discuss about hardness of water. In hardness of water, we will discuss about types of hardness, that means temporary hardness, and permanent hardness. And next we have to discuss about the determination of hardness used by complexometric method. Complexometric method means here we will be determining the hardness using EDTA. That means ethylene diamine tetraestic acid, which is a complexing agent. Next we have to discuss about the boiler troubles. Boiler troubles means these are the troubles which are going to occur in the boiler due to the usage of untreated water. So what are the major boiler troubles means? Priming, foaming, scale formation, boiler corrosion, and caustic embrittlement. Next we have to discuss about the internal treatments for resolving these boiler troubles. So next we will discuss about the softening of hard water. Here hard water can be softened using geolite process, and we will practice some problems related to the geolite process. And next one is ion exchange process. So in ion exchange process we will be using cation exchange resins, anion exchange resins. In detail we will discuss here. And next one is treatment of industrial wastewater. Next one is potable water. Potable water means water which is pure and which is free from disease producing microorganisms. And next we have to discuss about the specifications of this potable water. And next steps that are being involved in the purification of water. So what are the purification steps means? We can purify the water by chlorination or by breakpoint chlorination. Next one is desalination process. So the desalination methods that are employed are reverse osmosis and electrodialysis. And at the end of the unit, the students will be able to analyze the suitable methods for purification and treatment of hard water and brackish water. So these are the outcomes of this course, engineering chemistry. Thank you.